Welcome to Automatarium, the next-gen platform revolutionizing the way we explore formal languages and automata theory. Step into a modern, intuitive experience designed to empower your learning journey. Let's embark on a voyage into the core features and the magic behind Automatarium. This tutorial will focus on constructing finite state automata. Let's get started. A finite state automaton, or FSA, is a computational model that can represent regular languages. It consists of a set of states, a set of input symbols, and transitions between states. When you feed a string into an FSA, it moves from state to state based on its transitions and eventually decides if the string belongs to the language it represents. Let's try building an FSA for the set of all strings that start with A and end with B. Open the Automatarium webpage, click Start Building, and create a new finite state automaton. Here's our empty workspace. To add a state, click on the State tool and then click anywhere on the canvas to place it. Let's go ahead and add a few states. Right-clicking on a state unveils a menu, offering you the option to rename or label it. We need to set an initial state and a final state. We can find these options in the State menu. In this case, we'll set Q0 as our initial state and Q2 as our final state. Now that we have our states, we should define our transitions. Select the Transition tool from the toolbar. Click and drag from one state to another to create a transition. Let's create a transition between Q0 and Q1. A dialog box will appear where you can label the transition with a symbol. The default symbol is lambda, representing the empty string. We will change this character to an A. Clicking on a single state while using the transition tool will allow you to make a loop, effectively transitioning to the same state. Let's create a transition like this in Q1. Since our language is comprised of all words beginning with A and ending with B, we need to add a transition at this point for every letter in the alphabet. Rather than creating 26 separate transitions, we can simply specify a range. Let's change the input from lambda to A-Z inside brackets. Finally, we'll add a transition, B, between Q1 and Q2. Note that as there are two transitions for B from state Q1, this FSA is non-deterministic. Let's test some inputs on our automaton to check that it follows our requirements. Open the testing lab by clicking the flask icon on the top right of the screen or by using the keyboard shortcut Shift-1. First, let's explore the trace functionality. Input the string A, B into the trace field and then navigate through the input sequence using the directional buttons. You'll notice that this particular input is accepted and the trace panel illustrates the route the string took through the automaton. We can switch on the trace tape feature for a visual representation of the input tape. If you were to input a different string, say ABCD, the trace feature will alert you that there's no viable transition for consuming D when in state Q1, which leads to the input being rejected. If you'd like to test multiple inputs swiftly, the multi-run section has you covered. You can continue to add inputs by pressing Enter. Or alternatively, this feature allows for batch input. Just copy and paste multi-line text into a multi-run input field. The color-coded output and accompanying symbols make it clear which inputs are accepted and which are not. What if we wanted to alter the machine to accept all strings starting with A and ending with B, or the string ABC? Given that our machine is already non-deterministic, let's leverage this attribute to achieve our objective. While there are numerous methods to adapt the machine for the new language, we'll focus on devising an extension that's capable of vivid demonstration in Automatarium's stepping lab. Let's add another few states, Q3, Q4, and Q5. We'll add a transition, A, between Q0 and Q3, a transition, B, between Q3 and Q4, and a transition, C, between Q4 and Q5. We'll designate Q5 as the final state. We can again use the testing lab to verify that our machine functions correctly. Add the input ABC to the field and it will be accepted. If we wanted to see how the input traverses the machine step by step, we can use the Stepping Lab. Click the pause symbol in the right-hand toolbar or press Shift 2. Use the arrow buttons to step through each transition. The states will glow when they are reached. To completely reset and start again, click the button on the left. For an exhaustive summary of your machine, click the info symbol or press Shift 3. This reveals the machine's alphabet, state transition table, and transition function. And that's how you create an FSA in Automatarium. To share your machine, navigate to File, then Export. You have the options of exporting as an image, JSON file, or URL. With the close of this tutorial, your journey into the world of Automatarium is just beginning. Embrace the tools, the features, and the intuitive design that awaits you. Remember, every challenge in understanding is an opportunity for growth, and Automatarium is here to guide you through it. For more information, our contact details and a link to our GitHub repository can be found in the video description below.